Hey everybody, welcome to Mission Control Houston. I'm Dan Hewitt. Joining me here is one of our fantastic spacesuit engineers, Heather Paul. Again, you're inside the International Space Station Flight Control Room now, so all the people in this room are monitoring systems on an orbiting laboratory traveling at 17,500 miles an hour over 260 miles over our heads. So pretty, incredible stuff going on. Some of the stuff going on board the station today, a lot of science work. They're getting ready. There's a spaceship about to dock with it tomorrow, and all the guys and girls in this room are helping them get ready. There are currently 6 astronauts on board, and I know you guys have a lot of questions about just what happens to you when you go to space and things like that. So why don't we go ahead and jump right in and start off with your first question.
We've discussed how muscle contracts in depth. What is the physiology of muscle atrophy, knowing that is what happens to astronauts on the ISS?
This is a really great question, Dan, and it shows, that they've been talking a lot about physiology in their class, and that's really cool. Muscles contract and expand, and that's how we move around. And when you're in microgravity, because we don't have gravity acting upon our bodies, our muscles tend to be a little bit more relaxed because they don't have to work as hard. And that's why they atrophy or they degrade, because they're really not having to work as hard to contract and relax like we do here on Earth. And that's primarily what causes that atrophy or degradation of the muscle.
All right, very cool. Okay, next question, guys.
How quickly does the muscle atrophy begin to occur once on the ISS?
How quickly?
It's pretty fast, actually. In the early shuttle days, we realized how important exercise was when you're in microgravity, whether you're on the space shuttle or the International Space Station. And some of our early studies indicated that within just 5, even up to 11 days, our astronauts were getting about 20% of muscle loss. That's a lot of your muscle. And I mean, our muscles are really important to keep our body functioning and moving. So while they don't have to work as hard in microgravity, it's a concern when our astronauts come back down to Earth that if they've lost all of that muscle, they won't be as strong and capable of moving around. So that's why the astronauts actually exercise for anywhere from 2 to 3 hours a day using our different exercise machines up there. It's important that we don't lose that 20% muscle mass, especially when 5 to 11 days is far shorter than our current mission duration of 6 months and even up to a year.
Yeah, I mean, I've heard from a number of scientists, it's amazing how quick the human body can adapt to very foreign. I mean, microgravity is something that your body will never experience basically throughout your entire life. Within 5 days, it already starts completely changing. That's absolutely insane. All right, next question, guys.
Thank you.
You're welcome.
Astronauts take supplements to help neglect bone loss that occurs in zero gravity.
Yes, I think they asked the question about supplements.
Okay.
And this is important. I bet we all take vitamins here on Earth, right? Well, we have these really important people called food scientists that work with us here as part of our NASA team. And their job is to make sure that the food that the astronauts eat contain all of the vitamins and supplements that the astronauts would need. So they don't really take vitamins like what we do here on Earth. We make sure that the food contains all of the nutrients that they need. But I've heard that they actually do have to take vitamin D supplements to help, because here on Earth we can go step outside and just a few minutes in the sun we get some vitamin D. Well, they can't step outside the International Space Station so easily, and the vitamin D they would get is a little bit higher exposure than what we want. That's why they wear the spacesuit. So we do provide them with some supplements for vitamin D.
Okay, I did not know that.
There you go.
Great question. All right, next one.
What in your physiology makes the ISS astronauts nauseous in the first 48 hours? How does it read itself?
This is an important thing, and when I first got my job here at NASA, I was a student still studying engineering at the university, and I got to work with our life science team. And one of the things we were studying was space adaptation sickness. A lot of our astronauts, within the first 2 to 3 days of being in space, whether they've flown before or not, sometimes their stomachs can get upset and they get a little dizzy and definitely nauseous. And a lot of that is attributed to the fact that your body has all these sensory organisms and everything that's communicating back and forth with your eyes and your brain, and it's really just confusing for all of these sensors in your body when suddenly here on Earth we have a ceiling and we have a floor and we have walls and everything's upright and normal. Once you get in space, there is really no up or down. And so your eyes are looking at something and your brain is trying to understand it, and your neurovestibular system that's working to keep you balanced. All of these different sensors are talking to each other and the information isn't matching up. And that causes you to feel maybe a little dizzy. You might start to get a headache, and sometimes our astronauts do feel nauseous. But typically after a few days you get used to it because, as Dan said, our bodies are so amazing, we adapt nearly immediately. So sometimes that adaptation process takes a little bit longer for some of our astronauts, but they get better very quickly.
All right, next question.
Is there anything different about the air pressurization on the ISS in relation to that of the sea level on Earth? If so, does this have implications on the human body?
Very good question. I'm excited about this one because what you're asking is something that I've actually worked with on our team of life support engineers. And more specifically, I've worked with your atmosphere within your spacesuit. But our team that works on the atmosphere for the International Space Station does something similar. And maintaining that environment is very important. Now, the International Space Station is at the same atmospheric pressure as sea level, so that's 14.7 pounds per square inch, absolute. And the composition of gases is the same, just like what we're breathing here on Earth. We have the same up there. Now the spacesuit, on the other hand, because you're inflated in this suit that's protecting you from those extreme environments, we have that at a reduced pressure of 4.3 pounds per square inch, but it's 100% pure oxygen. So the spacesuit is slightly different, but it's sea level and regular atmospheric composition on the space station.
So what would happen if the spacesuit was at an atmospheric, like, would they not be able to move? Or?
Exactly, because when you're inflating, it's basically like a human-shaped balloon. And the more you pressurize or inflate that balloon, the harder it's going to be for the human being inside to move against those materials. That's why we wouldn't want a suit that's made out of fabrics, kind of like we have now, and pressurize it to atmospheric pressure, because it would just be really hard to move for our astronaut. And let's face it, when they're out on a spacewalk,
hard enough already.
Exactly. We want to make it as easy as possible.
All right, great question.
Okay. Is there anything different about the air pressurization on the ISS in relation? Is there anything different about the proportions of different gases that make up the air aboard the ISS?
Nothing different at all. Nothing at all. Now, sometimes when we're getting ready to do a spacewalk, the astronauts will go into the airlock, and we might decrease the atmospheric pressure a little bit, and we might ask them to put on masks to breathe pure oxygen. And the intent there is when you're going from an atmospheric pressure of regular air composition to a spacesuit pressure that's a lot lower and 100% oxygen, we want to get out all of those extra gases like nitrogen that stay in our blood and our tissues. If you've ever heard about scuba diving, you know that the astronauts, if they spend too much time underwater at depth, they have to take their time coming back up to sea level because they've saturated their tissues with nitrogen. And those nitrogen bubbles want to expand as you reduce the pressure around them. Well, we're doing the same thing when we go from a high pressure sea level atmosphere down to a low pressure spacesuit. You don't want those nitrogen bubbles to expand because that could be pretty dangerous to our astronauts' health. So that's why sometimes they do what we call a camp out in the airlock, and they get to overnight with their spacewalking buddy, have a little slumber party in the airlock at a lower pressure to get them ready for that lower, even lower pressure of the spacesuit. But the regular cabin environment is just like breathing air here at sea level.
All right, very cool stuff. Next question, guys.
And the kids were dying to have us let you know that we just went scuba diving. We learned all about that, so that was a pretty exciting connection.
There you
Perfect.
go. So see, now it's kind of the opposite. When you think about it, scuba diving, you go down in depth and the pressure increases and then you come up to sea level. Well, in space, we're floating and we're at sea level and we go down to spacesuit pressure. So it's a little bit different, but we do the same kinds of things to prepare, just like you would if you're a scuba diver coming up to sea level, taking it slow. We take them slow from 14.7 down to 4.3.
All right, cool. Next question.
Okay. What is the most common noticeable effect that astronauts still have when they return to Earth from a stint on the ISS?
That's a really good question, and it's a very personal response. So each astronaut reacts a little bit different. We've had some astronauts that come back and they hop out of their seats, walk out of the space shuttle, they're waving and feeling great. There are some astronauts that come back and maybe they feel a little bit dizzy or even nauseous. Sometimes it's a little harder to feel all of a sudden your arms are really heavy. You know, just to pick yourself up out of the seat could be exhausting. And really the response depends on how long you've been up in space. So the space shuttle astronauts who were up there for maybe a couple of days to 2 weeks at a time, it was much easier for them to adapt when they got back to Earth than some of our astronauts that live on these increment missions for 6 months at a time. So it's really very different for each astronaut, but one of the most common things that I've heard happens is they feel a little bit lightheaded, and that's because in space we get what we call a fluid shift. Due to the microgravity environment, our fluids, which on Earth tend to pull down in the lower half of our body because gravity is pulling down, well, all of those fluids redistribute in the body and they tend to kind of creep up into the upper half of the body, which is why our astronauts, sometimes when you see a picture of them on Earth versus in space they look like they've gained weight. Well, they haven't gained weight at all. They've just got a little bit more fluid in their upper body and their faces puff out just a bit more. Now, your heart gets used to that and it thinks, that's cool. I don't have to worry about making so much blood and pumping so much blood. And so when you get back to Earth and our astronauts land and gravity pulls the fluids back down into the lower body, sometimes our astronauts get a little bit dizzy. You know, they feel a little disoriented, but again, they adapt pretty quickly to their back home environment.
One of my favorites that I have heard from a few astronauts, not really a physiological, almost more of a psychological, is they'll forget that they're not in microgravity. So they'll hop out of bed one morning, grab a glass of water, and then go to just let it float away, and plop, drops right on the ground. So it can be difficult when you, live a certain way for 6 months to suddenly go back to the complete opposite, even if it's where you've lived for your entire life. It's more your body adapts very quickly, and your mind does as well. All right, cool. Next question.
All right, so at what point in time were the exercise machines that are currently being used on the ISS installed?
That's a good question. Now, remember, before we built the space station, we were flying the space shuttle. So we'd already been doing a lot of experiments to understand to what extent we needed to exercise if we lived for long duration in the space station and what kinds of machines we would need. So I don't know exactly when we first started bringing up exercise equipment. I believe it was when we first brought humans up.
One of the very first pieces of exercise equipment that was on board the station actually just left the station. It was the very first treadmill, which was on one of the Russian segments that launched back in the first Russian segment that launched back in 1998. So there has been exercise equipment on board the station, since the station's been in existence. Humans got there in 2000, and there was already exercise equipment waiting for them. One of the ones you might have heard of is known as the Colbert. It's one of the treadmills on board the International Space Station. This was named after Stephen Colbert. You may have heard of him. It's the Combined Operational Load-Bearing External Resistance Treadmill. We love acronyms. But that one launched back in 2009 on one of the space shuttles, and that's one of the more recent pieces on board the International Space Station.
And we've definitely been making upgrades to the equipment as we learn more about what the astronauts like to do and the effects of that exercise on their bodies. We can't do traditional weightlifting in space because you're weightless, so would those big barbells that you'd be lifting. So learning how to do something like resistive exercise. So it's not just about the cardiovascular effects of running on a treadmill or working on a bicycle. We have to really make sure that we're doing that resistance exercise as well, to make sure that they're maintaining their bones and muscles.
Yep. All right, next question.
acronym was it acronym came first and then you decided to name it after Colbert, or was it first we have to find an acronym that fits for Stephen Colbert?
We had to find an acronym that fit. Sometimes you'll get a cool name, and we have some very talented people here coming up with acronyms.
Yes, as an engineer that works on a lot of different pieces of hardware, we're always really trying to figure out how could I make the name Heather into an acronym for that piece of equipment. One of our engineers came very close. His name is HEP, H-I-E-P, and we were working on something that became EHIP. So he got really close. He was so excited.
All right, next question, guys.
Astronauts always known that they needed to exercise while in space to combat muscle atrophy and bone loss since the beginning of ISS, or is it a recent revelation?
Yes, absolutely. It's a big concern because, again, microgravity, your bones and muscles, your tissues, they tend to relax. It's almost like they're on a vacation because they don't have to work as hard. And that muscle atrophy is really serious. Like I said earlier, you can lose up to about 20% within the first 5 to 11 days if you're not exercising. And it's not as critical up there, unless you're a spacewalking engineer or astronaut, and then you definitely have to make sure that you are still strong enough to do the operations. But there's more of a concern here on Earth. And the other thing is the bone loss. That has been a big source of our studies because your bones degrade at a much faster rate in microgravity compared to here on Earth. And in fact, they can lose about 10% bone loss in 1 year in microgravity. That's equivalent, 10% bone loss is equivalent to what someone age 50 or higher would lose in 10 years here on Earth. So really making sure that our astronauts are eating a good diet that provides all the supplementation and nutrients that they need, and they're doing that exercise for about 2 to 3 hours a day.
And also, part of your question, this is something that we've been aware of. We've been doing space flights since the 60s, so it is something, if it only takes 5 days to appear, then you can have noticeable effects. It's really become a priority, since the advent of space stations in space, like the old Russian Mir, and also the U.S. Skylab missions, but especially on the International Space Station, and it's such a huge part of the ISS nowadays because we have these continuous crews. We've had people in space since the year 2000. Like, human beings have been a spacefaring civilization since the year 2000. So we now have the capability to do constant research and have lots of test subjects so we can really, examine what causes this muscle atrophy and bone loss and how can we really combat it.
It's really exciting, Dan, because we have selected our first astronaut and cosmonaut to do a 1-year stint on the space station. And that astronaut has an astronaut twin brother who's going to stay here on Earth. And our International Space Station Program Science Office has set out a notice to scientists around the world saying, we've got one astronaut brother up and one astronaut brother down, and they're the first, set of twins where one will be in space and one here for a full year. What can we do to study the effects of microgravity on one versus the other? I think that's so amazing.
It's really exciting stuff coming up in the next year or two.
Absolutely.
The research never stops. All right, next question.
Okay, so does the lack of restful sleep and that most astronauts tell us on the ISS contribute to the muscle atrophy and or bone loss?
I haven't heard that lack of sleep really contributes to that. I think it's more the environment around them. But what lack of sleep might do is just make them a little bit more tired throughout their day. Although most of my astronaut friends that I've talked to said after that first few days of getting used to things, they actually sleep really well when they're on the space station. And I think one of my favorite things when I think about how they sleep, they're basically in a sleeping bag, but we had to develop a head strap because naturally when you're in space, your arms are going to float up and your head will tilt forward. And then that's a little bit uncomfortable for the neck. So our engineers who designed their sleepwear had to design a comfortable head strap so that the astronauts can strap their head back and get that sense of the contact of the back of their head on the sleeping bag, almost like they're sleeping on a pillow.
All right, great question, guys.
What is the process for re-entry into the Earth like for astronauts? Does it take them a while to become accustomed to gravity again?
So I think the question is about reentry.
Mm-hmm.
Yes, so it takes quite a bit of time because, it's basically like they're packing up after they've been on a really long trip. They want to make sure everything is packed up and secure, and they want to make sure that their suits that they're wearing for reentry are working well, so they do a lot of different checkouts. So it can take several hours for them to prepare for reentry, and then really once we're ready for them to go, they strap into their seats and then we fly them back home.
Mm-hmm. And once they're down, like Heather had said earlier, it affects the astronauts differently. We've had some that they land, they hop out, they can walk on their own, they're totally fine. Others might need a little assistance. It really varies from the individual. Next question.
Real close to Michael.
Okay. What types of activities did the astronauts do on Earth to prepare them for the rigors of living zero gravity short-term training?
Well, the astronauts do a lot of training once they get selected for a mission. It can be several years. And part of that training is to get them used to the different things they're going to be doing on the space station. So we have a lot of different trainers here, some of which stay gravity-based, and they just do their operations in our mock-ups. But we have a really big swimming pool called the Neutral Buoyancy Laboratory, and it's big enough to sink several of our modules for the space station. When we were flying the shuttle, we sunk the cargo bay of the space shuttle as well. And that's where our astronauts get the most training. For every 1 hour that they're on a spacewalk, they do about 8 hours underwater. Now that's primarily for our spacewalking astronauts. With our astronauts that maybe are early on their selection process or need to get that feeling of what it's like to float in microgravity, we also have a very special aircraft called the Vomit Comet, for reasons that it flies parabolas over the Gulf of Mexico. And when you're on that downward part of the parabola, everyone's floating inside because you're not strapped in. It's like a big roller coaster that you fly up and down multiple times. And that's a good way to get them kind of a feel for what it's like to be in microgravity, but you're only floating and free falling on that plane for about 20 to 30 seconds. So other than that, it's really hard to tell people what it's going to be like to float in space until they get there. And the best simulation we can do is really to float in water. That's about it, though.
Next question.
Really close to Mike.
Were they all athletes to begin with? If so, what were their favorite sports activities that kept them in shape? Or did some of them have to whip themselves into shape or in order to apply to be an astronaut?
Well, the health consideration is a very big part of the astronaut selection process. We do a full physical, we do several psychological interviews. So the astronauts have to be very healthy before they even get selected. And then a big part of their training is to maintain their health. We actually have personal trainers that work with the astronauts every day to make sure that they are getting enough cardiovascular work, exercise, they're maintaining their bone and muscle mass here on Earth, and even maybe bulking up a little bit before they go, so that when they lose a little bit of that bone and muscle, even with all the exercise they're doing, they'll still be strong enough to return home. Now, several of our astronauts maybe weren't necessarily athletes, like professional athletes, although I do know of one who was a professional football player. But most definitely our astronauts are very athletic, and a lot of them grew up on, football teams, basketball teams, volleyball teams, growing up through high school and maybe even in college. So definitely the astronauts we select recognize the importance of health and exercise, and a lot of our astronauts today still do many different athletics, intramurals, and they're on clubs and teams.
All right. Well, unfortunately, I think that's all the time that we have today for questions. Really want to thank you guys for, coming on and asking us. Hope we gave you a couple of cool answers and you enjoyed getting a look inside of Mission Control Houston here. Again, it was a real pleasure for us. Thanks again.
Yes, thank you so much, and I'm excited that you guys are in Durango. I've been there, so nice to talk to all of you. Thank you so much.